Hello, guys and gals, me Mudahar, and ladies and gentlemen, what about some good news in the world of cyber wars and hacking? What if I told you hackers absolutely failed yesterday? Now, ladies and gentlemen, some big things kind of kicked in. I know some of these videos are a little dry and techie for some people. They're like, Muda, come on, when do I ever load up a terminal shell? Ladies and gentlemen, if you have any idea about programming, computer stuff, or programming software, anything of that nature, you've probably heard of Git. You've probably heard of GitHub. Now, GitHub is a great website where millions of projects are shared every day and millions of collaborations are happening. Quite possibly, it is one of the most collaborative websites one could ever get onto. Now, of course, did GitHub get hacked yesterday? Ladies and gentlemen, to understand, if GitHub gets hacked, one of the largest code collaboration websites, the software you're probably using is hacked as well too. Hacking GitHub is like hacking the international software supply chain. Some real scary shit if it actually happens. Now, a software engineer by the name of Stephen Lacey was actually working on a game known as Godfall. You may have played it, you may not have. A person who loves DevOps and open source. Me too, buddy. But of course, when it comes to it, he made this one post that got a lot of viral attention yesterday. And this is, I am uncovering what seems to be a massive, widespread malware attack on GitHub. Currently, over 35,000 repositories are infected. So far found in projects including Crypto, Golang, Python, JS, Bash, Docker, K8s. Now, to understand if this is absolutely true, this is one of the largest software supply chain hacks to actually happen. Now, in Stephen's investigation in his work, he basically found 35,000 results, all containing one string. This string happened to be http://ovz1.j195445519. You get the entire URL. I don't have to go all the way in. Now, why is this necessarily spooky for people? Well, to understand that link, you don't have to be a computer engineer to realize it's linking you to a shady little server that's going to probably download a nasty little program onto your system. Now, this has been replicated in 35,000 different repositories. Now, of course, where this sort of story thankfully gets into some positivity is it doesn't seem like anybody actually got hacked. At first, people were kind of freaking out, wondering, holy crap, are 35,000 projects actually compromised? And that's just what we know of. Well, to understand, ladies and gentlemen, I got to teach you how GitHub works. Now, GitHub, all right, the first part of that word, Git, is the most important. Git, for those of you who have no idea what Git actually does, Git is effectively a version control software, okay? It's a version control scheme, and the way that it works is it allows you to track changes in sets of files, and it's great for people who are collaborating in large programming projects. Basically, when you're working with massive amounts of source code across the world, or even in a local center, you want to make sure you have a Git system running so that you can handle version control absolutely effectively. To give you a quick example on how it works, here's a quick little graph provided by Noble Desktop, which I can use to best explain. Now, the way any project works is that it has a master branch. The master branch is where all the code that ever has to be worked on is staying, okay? The master branch is sort of the heart of a project. Now, with, let's say, 10 people working on a project, okay, just for this example, let's say you and another person are working on the project. Now, what will happen is you will basically branch off, take that master branch, work on your own branch, add your own code to it. Now, you might think your code is so awesome that you want to put it back into the master branch, right? Let's say this project is OBS, Open Broadcast Software. A lot of streamers, content creators use this software. Now, the programmers who build this, one could say, hey, let me add this feature to OBS. They take it out, they add features to OBS, and then they're like, this is so good, I want to send it back to the master. So what they do is basically they've pushed this out into their own branch, and what they do is they submit a pull request. If everyone in their mother was allowed to basically push their code back into the master branch, the whole OBS project, in this example, would be a shit show. So what happens is when they issue a pull request, which is basically, hey guys, my code is good, can you guys consider it for the master branch? So administrators and other people that are basically, spearheading and, basically overseeing and moderating the project will say, yeah, your code's pretty good. It's not conflicting with anything. We think it's a banger. Let's put it back in. So then it gets merged back into the master. Now, somebody else on the other side of the world might be like, yo, I got something that I want to add to OBS. Well, same principles apply. They'll take it out into their own branch, work on their code, and then they'll do the pull request, and they'll be like, hey, guys, can you take my code and, put it back into the master? And maybe it'll get accepted, maybe it won't. There's a lot of ways that conflictions are sort of analyzed, and a lot of issues are sort of figured right at the source, so that, nothing really conflicts with one another, everything works, the versions are controlled, and there's just a healthy code that's sitting there, ready to be collaborated on by millions of people around the world. This covers every single project. It could be some stupid little Hello World project that you're working on with 10 people, or the Linux kernel, which basically, in a lot of ways, powers the entire internet. The video you're watching is thanks to a server that's powered by Linux somewhere. So to understand, that's kind of how Git works. Now, what actually happened was 35,000 projects did not actually get hacked. Thank fuck for that. What actually happened was people forked the code 35,000 times, but actually modified that code to contain malicious backdoors. Now, the way forking works is, let's say we go back to that OBS example. Now, let's say that you wanted to make a fork of OBS. You wanted to make your own version of OBS with blackjack and hookers. What you're going to do is you're going to make a fork for it. You're going to make a different version of OBS. You're going to take the branch and you're going to basically start your own Git project using that code. That's how a fork works. So what they did was they took respectable code, respectable, projects, and just forked them. The exact same project, just with their own added malicious backdoor. That's what these malicious malware inducers were basically doing yesterday, or 2 days ago. Actually, this has been going on for about 14 plus days, so surprisingly, it's not been good. In fact, some of the changes alone were rather hilarious. What they would do is, basically they would target some of these projects, and the tiniest change would just be, hey guys, let's go from version 0.310 to version 0.311. They were trying to fly real under the radar, but thank God we actually ended up basically catching on to this URL and realizing it wasn't just one forked project, it was 35,000. Because of this, GitHub jumped in and basically cleared the entire situation. They claimed that no repositories were actually compromised, those host branches. The malicious code was literally just those forked clones. That's about it. And of course, because they were all just forked clones, GitHub immediately jumped in and cleared it out of the situation, meaning that anybody who tries looking for this code now will not find any repositories matching. That's not to say, ladies and gentlemen, that in some cases there couldn't be other links floating around on GitHub. But for anybody worrying that the big main projects were fucked around with, luckily, you are safe. Now, this really brings me into the whole question and why I wanted to talk about it too, is this is a great example of basically making sure whatever you download is actually from the source. From time to time, I've probably told you, hey guys, make sure those checksums are there. Make sure whatever you downloaded from whatever website you were downloading from is actually the file that you requested. Because of things like man-in-the-middle attack, somebody could send a malicious file to your system. And unless you were checking those, MD5 hashes, those SHA-512s, unless you were checking all of those checksums, you might have possibly gotten malicious software, right? You might have possibly installed something malicious. It's kind of like going and downloading Discord, but instead of going to discord.com and downloading fresh from their file server, you went to some weird, shady phishing website and downloaded a hacked Discord client from them. You got to make sure whatever you download is straight from the source, okay? It better be milk from the goddamn cow. Now, as somebody that uses Linux systems, I will remind you that for me, when I download source code, I play around a lot with GitHub, and I'm sure some of you watching this video have downloaded a project or two off of GitHub. And it's got to be something that from time and time again, you got to make sure you're actually looking at what you're downloading. Because let's say that you're downloading RPCS3, the emulator we talked about a few days ago, right from the source. Well, you want to make sure it's literally from the RPCS3 developers and not some malicious hacker somewhere who's forked that project and added a little secret sauce of their own. This is something that you have to absolutely pay attention to. Hey guys, Future Munahar here, and ladies and gentlemen, the story and the plot even thickens beyond it, because it seems as though this was introduced by one person who wanted to do a bit of bug bountying. Now, for those of you who don't know, when it comes to cybersecurity, bug bounties are a big thing. It's how we try to find security holes and basically report them to, security groups, security companies, if you will, companies like Apple, GitHub in this case, to make sure that their security is up to date. Now, in this case, a user, a bug bountier known by Plox Chicken Pox, Look, I don't come up with these names, buddies. But this is a mere bug bounty effort. No harm done. Report will be released. Now, I can't wait to read this report if true. I don't even know if this person is doing it. Maybe it's a troll out there. But to understand, this brings to another story and why you shouldn't ever do something. You know, when you're doing any form of cybersecurity work or research or, bug bountying, you should never, and I mean never, run your experiments in a public-facing environment. You never want to put this into the public face. Ethically, that is fucked. And let me explain why. Obviously, it's because if you release malware into the public chain, somebody could potentially download it. If your malware steals possible credentials, runs backdoors, you're not really doing an experiment. What you're doing is an illicit, illegal crime in the public. You're actually hacking people. There was a point in time where the Linux kernel and the University of Minnesota got into some goddamn fucking drama. Now, if that wilds you out, whoa, there's beef between... Yes, there is plenty of them. Of course, there's an entire series I could make. But back in the day, the University of Minnesota had two researchers, and this is about a year ago, so 2021 actually, is when they submitted hypocrite-like updates. They submitted fake patches to basically prove a point that somewhere in the supply chain, the Linux kernel could be infested with security holes. Now, of course, they never succeeded because the Linux kernel maintainers never actually put it in. But I'll read you a few emails from this. Now, at some point, 21st of April, 2021, literally after 420, I have been meaning to do this for a while, but recent events have finally forced me to. Commits from unm.edu, University of Minnesota, addresses have been found to be submitted in bad faith to try to test the kernel's community ability to review known malicious changes. The result of these submissions can be found in a paper published at the 42nd IEEE Symposium on Security and Privacy entitled Open Source in Security, stealthily introducing vulnerabilities via hypocrite commits. Because of this, all submissions from this group must be reverted from the kernel tree and will need to be re-reviewed again to determine if they actually are a valid fix. And of course, looking further into their emails, on April 20th, 2021, now it's 420, in response to the perception that a group of UMN's researchers have resumed sending compromised code submissions to the kernel, Greg Crow Hartman asked the community to stop accepting patches from UMN. Ladies and gentlemen, they quite literally got banned. A university got banned from helping maintain the kernel. All because they decided to do their little experiment in a public-facing sector. To understand why this is bad, like I said earlier, Linux is one of the largest open source projects, if not the largest. It powers a lot of the internet and servers around the world. If you're willingly introducing security holes to prove a point into a public-facing sector, you are a dick. Ethically, this is wrong. And if this is the case, well, ladies and gentlemen, this is one social experiment that should never have happened. That said, always be careful where you download things from. And if you're a researcher that wants to do experiments like this, please fucking don't. That said, though, if you like what you saw, please like, comment, and subscribe. Dislike it if you dislike it. I am out.